First rule or second rule? Anybody?
Second one.
Good job. The second one. So 2 times 5, that's 10. And root 3 times root 3. According to this rule, when this number, so the number under the square root symbol, if it's the same, just like in this case, we have 3 here and 3 here. So the number under the square root symbol, they're both the same. So according to this rule, when that happens, the answer would just be the number. So the square root of 3 times the square root of 3 is supposed to give me back 3. So that's times 3 is equal to 30. Anybody does not understand this rule? Like last class, I explained how this rule works using an example. You understand?
Yes.
Yes? No?
Yes.
Okay. If anybody doesn't understand how this rule works, let me know. I did an example last class, but if you want me to, I would do it again, just to show you how that rule works. Okay. So that was that. Back to the question. Anybody writing this down? Yes, no?
Yes, miss.
Yes, miss.
You writing it down?
Yes, miss.
Yeah.
Okay, let me know when you finish.
Finish.
Okay, anybody else writing?
Me too.
Okay. So back to the question I wanted you to do. I asked you to do this question for me. 3 plus 4 root 5. 5 root 3 minus 2 root 5. And we already said that we would multiply this by the conjugate. And we found out that the conjugate is 5 root 3 plus 2 root 5. But we need to multiply both numerator and denominator. So remember, if anybody doesn't understand, let me know. If you need to review what a conjugate is, you can let me know. And there's the recordings in Google Classroom. Right. So what we were doing just now, before we took that little detour, we are expanding this numerator. So we said when we expand this, we'll get 2 times 5, 2 times 5 times root 3 plus, it was 2 times 2 root 3 times root 5. That's what we were doing before I was explaining that other thing just now. Yeah? We're just expanding this expression multiplied by this expression. And this is what we got when we did that. Then it's 4 times 5 root 5 times root 3. Last one, 4 times 2 root 5 times root 5. Okay, so I just dealing with the numerator right now. Since this one is kind of long, and it will be kind of confusing if I try to do both numerator and denominator at the same time on the screen, because this alone is the numerator. If I try to do the denominator now, you might get confused. So just doing the numerator first, and then I will show you the denominator, and then we will put it together, and I'll show you the final answer. So this is just numerator. Put capital N for numerator, right? Okay, but we know we don't just leave it like this. This could be simplified even further. So let me just write the rules up here. Remember, when multiplying surds, these are the two rules you look at. A times root B. Oh my, that's a B. Is the square root of A times B. And then the square root of A times square root of A is equal to A. So just keep those in mind whenever you're multiplying surds. So let's simplify this. We already said that this was 30. That's what we were doing just now, the 2 by 5 and then root 3 by root 3. Right. So 2 by 2, that's 4. And this, root 3 times root 5. Looking at this rule, this would become the square root. Repeat.
No, Miss, it will become 15, Miss.
It would be what?
15, Miss. It will become 15.
15.
Yes, Miss.
Yeah, so let me just take off this bracket because that didn't make any sense. So 3 times 5, that's 15. If anybody does not understand how we got that, please let me know.
45.
Right.
45. No, 60.
16?
60. 60.
Where you get 60? I get 16.
It's 4 times 15, Miss. That's 60.
That's not what we do when multiplying. Okay. So let me just finish this. And this would be 8 root 5 times root 5, according to this rule, would give me back 5. So that's 8 times 5 would be 40. Remember we did this last class, eh? Okay, so you were telling me just now. You're saying 4 times 5, 15, which is 60. But that's not what we do. Can't do that. Okay? This is the square root of 50. Look at this rule. The rule says the square root of A multiplied by the square root of B. Do you see a square root sign anywhere here? Do you see a square root sign over the 4? Yes or no? Is there a square root sign over the 4?
No.
Exactly. So this rule does not apply. The rule says a surd multiplied by another surd would give me this. This is not a surd because you do not see that square root symbol anywhere. So this rule does not apply. It remains like this. 4 times the square root of 15. If anybody does not understand that, please let me know. But we don't just stay right here. We don't just leave it like this. We could simplify this even further. We know that 30 times 40, that's 70. And we also learned how to add surds last class. We said the only surds that can be added or subtracted are like surds. And what are like surds? Like surds have the same radicand. What is a radicand? So this is what the simplest form of a surd would look like. K is just a constant, and A. The radicand is this right here. So whatever number you see under the square root symbol, that's called my radicand. And like surds have the same radicand. So what does that mean? Like surds, the number under the square root sign would be the same. That's how you know if something's a like surd. 15 is the same as 15. Both of them are 15, so these are like surds. Therefore, we can add them or subtract them if we need to. Hold on my chat. Wait, 70. 30 plus 40. You good now? Oh, you said never mind. Didn't even see that. Okay. That's how we got the 70, yeah? This number plus this number will give me 70. Right. Back to like SIDS. We know that like SIDS can be added or subtracted if they wanted us to do it. In this case, we need to add them. And we can't add them because these are like SIDS. How are they like SIDS? They have the same number under the square symbol. Both of them are 15. So that means we can add them. And what's the rule? The rule for adding SIDS is this. Remember, we did this last class, right? So let me just write it down here. A square root of B. Oh my, hold on. The mouse is acting up. We did this last class, yeah? When adding SIDS, it's A, the square root of B, plus C, the square root of B, is equal to, oh gosh, you can't see that. A plus C square root B. How exactly did they come about with this formula here? Well, if you did factorization, right? Looking at this term here, so that's I'll just put a 1 here. And then I look at this term here. If we wanted to factorize this, we could say, okay, both terms, A root B and C root B, they have root B in common. So I could take out that root B. So that's why it's here. And what I remain with is A plus C. So just regular factorization. That's how they came about with this formula here. Remember we did that last class, yeah? That was just a recap. Right. So now looking at this formula and looking at the numbers that we have. This would be 4 root 15 plus 20 root 15. That would be A plus C. So in this case, it would be 4 plus 20. And then you have root B outside. And in this case, it would be the square root of 15. We could simplify this even further because we know that 4 plus 20, that's 24. And that's why my numerator, remember this was just the numerator that I'm working out, yeah? Is 70 plus 24 root 15. So, everybody good with that?
Yes, miss.
Yes, miss.
Okay. If you're not good with that, let me know. Okay. That was our numerator. We're not done yet. I just didn't want to have too many things on the screen at the same time. You still have a denominator to work out. So, anybody writing this?
Yes,
No?
miss. I finished writing this. Everything.
Okay. Okay. Well, I would erase then. Erase. This is just like a recap of what we did last class, because we did questions like these last class. This one is just a bit longer than the rest of them. But it's the same concept we're using. Okay, erase. Okay, that was the numerator. So let me just put equal to. We got this as the numerator. 24 root 15. But we still need to find our denominator. How do we get the denominator? We said it's 5 root 3 minus 2 root 5 multiplied by 5 root 3 plus 2 root 5. Remember, this is the conjugate. So let me do the long way first, and then I'll show you the shorter way. I showed you the short in the last class, but I'm not sure if you would remember that. Minus 2 root 5. This is the denominator. This multiplied by this. And 5 root 3 plus 2 root 5. So this is the long way. You could use the distributive law and expand these brackets. So what would I get? First, it's 5 root 3 times 5 root 3. That would give me 25 times 3. I skipped a few steps there. If you don't understand how I got 25 or how I got the 3, please let me know. Instead of doing it step by step, I skipped some steps there, right? So 5 root 3 times 2 root 5 now. That's plus, that would be 10 root 15 minus 2 root 5 by 5 root 3, that would be minus 10 root 15, and then minus 2 root 5 plus, no, not plus, minus 2 root 5 times 2 root 5, that would be minus 4 times 5. Simplify this even further to get 75. These would cancel because if I had, for example, so let me just put e.g. 1 minus 1, we know that's 0.
0.
Exactly.
Plus 0. Okay, go back to 20.
So if I put 10 root 15 minus 10 root 15, they would cancel out. But let me just do it the long way to show you, just in case anybody isn't seeing it. So we know the formula that we would look at when subtracting surds, like surds. Remember, these are like surds. They must be like surds in order for you to add them or subtract them. These are like surds. Why? Because the number under the square root symbol is the same, 15 and 15. And the rule is when subtracting surds, it's a root b minus c root b is equal to a minus c root b. And it's the same factorization concept that you're using like when we were adding surds. So you see a root b, and you have, let me use the boxes because I think that'll be easier for you to look at. So I have these two terms. I see what they have in common. They have the square root of b in common. So I could say, okay, if I wanted to factorize this, I could take out that square root b. So I take out the square root b. And what do I remain with? A minus c. And that's how they got this equation. So now back to our example. 10 root 15 minus 10 root 15. According to this rule, it would be 10 minus 10 root 15. And then we know that 4 times 5, that's 20. So this is just for me to show you why these here would cancel. 10 minus 10, that's 0. And we know that anything, any number multiplied by 0 would give me back 0. So let me just put the 0 here, minus 20. And this would be 55. Why? 75 minus 20 is 55. And that's why 55 is my denominator. And I want you to notice the whole point of rationalization was to get rid of the surds in my denominator, right? The surds are these things with the square root symbols. We wanted to get rid of them. Why? Because that's just not it. We do not want a surd in our denominator. And that was the whole point of rationalizing. Now we don't have any surd in our denominator. We just have 55, which is a rational number. Where did you get root 15? Wait, where does the root 15 go? Here? Oh gosh, I didn't see. Can you do step by step? Okay. Right here? This is what you're saying. Yes. Okay. 0 multiply by the square root of 15. Anything multiplied by 0 is going to give me back 0. And if you have a calculator with you right now, you could actually punch this into a calculator. Put 0 times the square root of 15, you're going to get back 0. And that is why I have the 0 here. You good now?
Yes, miss.
Yes, miss, I understand.
Okay. And you wanted me to do it step by step. Okay, so everybody finish with this on the screen? I'm just going to do it step by step now.
Yes,
Yes,
miss.
miss?
Yes, miss.
Someone wants me to do it step by step, so I will do it step by step. Need to make sure that you understand. Okay. So we said we're using the distributive law to expand these brackets. This will multiply by this first, because it has the distributive law. Root 5 by root 3 multiplied by 5 by root 3. Right. So that would be 5 times 5. Remember, these constants just multiply like usual. And then the thirds will multiply. So root 3 times root 3. Okay, so that's the first thing done. Continuing the distributive law, it would be this term multiplied by this one. So that's 5 root 3 by 2 root 5. That would be 5 times 2. You multiply these constants like usual, and then you multiply your thirds. Next one. So let me just put a minus sign. Minus 2 root 5 times 5 root 3. That would be your 2 times 5 like usual. You multiply them like normal. And then the square root of 5 times the square root of 3. Last one. You multiply constants like usual. So that's 2 times 2. Oh my. 2 times 2. And then you multiply your thirds. So that's root 5 times root 5. You good with that so far? Oh gosh, wait, my chat. Okay, you good with that? Yes, no? Hmm. So these are the formulas we're looking at right now, right? We don't just leave it like this because, like this whole long thing, because we know we could simplify that further. 5 times 5, that is 25. Okay, so let me put 25. When multiplying thirds, remember you're looking at these roots. The first one and the second one here. Both of them, these numbers here, are both 3. So I know I could apply this rule here that says root a times root a would give me back a. Therefore, the square root of 3 times the square root of 3 is going to give me back 3. And that's why I have 25 times 3 here. Next one. So put back my addition sign. 5 times 2, 10. The square root of 3 times the square root of 5. You know, when multiplying surds, we have these two rules to look at. What you need to determine is which rule you're going to use. You're going to use this one, or you're going to use this one. These are unlike surds. How are they unlike surds? Because the number under the square root symbol, they're different. This one is 3. This one is 5. So you know, you're not going to use this rule, you're going to use this one. So that's the square root of a times the square root of b is the square root of a times b. So that's going to be the square root of 3 times 5, which is 15. Next one. 2 times 5, that's 10. But look in, this is a minus sign. So let's still put in this in brackets. 10 square root of 5 times the square root of 3. These are the two rules you're always going to use for multiplication. When you see multiplication of surds, you're either using this rule or this rule, and you just need to determine which one you have to use. These are unlike surds, so you know you're going to use this first rule here. And get 5 times 3, which is 15. Last one, put back your minus sign. 2 times 2 is 4. And looking at this one, we know that this rule here would apply. Why? Because these numbers are the same, 5 and 5. According to this rule, the square root of 5 times the square root of 5 is going to give me back 5. And that's why we have 4 multiplying by 5. You good with that? Yes? No? Okay, you good with that? But we can't leave it like that because we know that we can simplify them even further. Wherever you can simplify, not just for this topic, yeah, for any topic in maths. If you could simplify, you have to simplify, else you're probably going to lose the marks. Maybe a 1 mark, but you would still lose unnecessary marks because you didn't simplify fully, right? So 25 times 3, that's 75. We said that these would cancel. You need me to show you why they cancel? Yes or no? The 10 root 15 minus 10 root 15. Yes, no? Okay. So remember these cancel, so that's the 0. And minus 4 times 5, that's 20. And this is going to give me 55. So that's how I got the 55. That was just me showing you step by step instead of skipping these steps like I did just now. Okay. That was the long way. So let me just show you the shorter way. The long way is using your distributive law like just now. So one term times the next one, so on and so forth. This is the shorter way. I don't know if, well, you probably did come across this term already, difference of 2 squares. And it says that a squared minus b squared is equal to a plus b times a minus b. And just a little hint, all the conjugates are like this. Like you see the ones with the 2 terms? This rule right here, the difference of 2 squares would always apply. A squared minus b squared is the same as a plus b times a minus b. If I said this was my a, so and this was my b. Looking at this, a squared minus b squared, they say the rule says that it's a plus b, so a plus b multiplied by a minus b. That's why this rule here applies. So instead of doing all of that, distributive law and all that, I could say, okay, this here is my a, this here is my b. And according to this rule, I'm supposed to get a squared minus b squared. So 5 root 3 squared. 5 root 3 squared minus my b squared. B in this case is 2 root 5. So I have 2 root 5 squared. But we don't just leave it like this. Why? We could simplify this even further. Remember, the whole purpose of this rationalizing is to get rid of this third. I do not want the square root. I don't want this. I need to get rid of it. So we know that we could simplify further. Remember, anything, if we say you square, if you say you're squaring a number, that just means that you're multiplying it by itself. So 5 root 3 squared is the same as saying 5 root 3 multiplied by 5 root 3. Remember, squaring something means I just multiply it by itself. Minus, you're doing the same thing here. If I say 2 root 5 squared, what I mean is 2 root 5 multiplied by 2 root 5. So that's 2 root 5 times 2 root 5. We could simplify this even further. Remember, the whole point of rationalizing is to get rid of my square root symbols. Okay, so what color to use? Let me use the red. I can simplify this even further. So when I simplify this using the rules, what I'm going to get is the 25 times 3, just like we worked out just now, which would give me 75, minus, when we worked out this just now, we get 20, which would give me the 55. So instead of doing the whole distributive law thing, this little trick, well, tip, the conjugate, when finding the conjugate, so when you have two terms and you're using the conjugate, this rule here would always apply, a squared minus b squared. So you would always be able to do this and get this answer. Okay. So you understand that? Or no?
Yes, miss. The second way easier.
Anybody does not understand? Okay. Well, what time is it? I wanted to do indices with you, but I don't think I will do indices today. I have a quiz. I have a search quiz. So I think we would do that now. Does it make sense? Okay, I think we'll do it now. 42 minutes, huh? I think I would do it now. So stop sharing. Everybody was good with that, right?
Yes,
Anybody else writing that down?
No, miss, I finished writing.
No.
Okay. Okay. So I have a search quiz for you. I think we should do it now. Yes. And I would post the solutions for it. And if you have any questions, you can let me know. Okay, so just hold on a bit while I get it. You could use your book if you want to, or whatever you're writing your notes in. Doesn't matter, but you should try to do it without looking at anything. Oh gosh, hold on.